Good morning, guys. Welcome back from spring break. Hopefully, your spring break in place was not too bad. I don't know about you guys, but I've had like several people ask, like, did you guys do anything fun over spring break? Or did you guys go anywhere? Or are you guys going anywhere for vacation? No, I'm locked in my house with my four kids, or two kids. There's four of us. We've played board games and video games and watched TV, occasionally went walking. That's it. Just like everyone. So don't ask that question. Yeah, I'm totally good. I'm venting to my students. My wife was worried. She's like, you sound a little scared. Anyways, here we go. So this week we have a test that's on Tuesday. I'm going to go through the three sections you need to know for the test, okay? Quick review over like some highlights. So if you're watching this video, pay attention to the stuff that I'm talking about because I'm talking about the things that are going to be on the test. You can never see, I always like do a thumbs up, but I'm always just off the screen a little bit. Okay, so first thing, arcs, central angles, what do they call it? I can't remember what they, inscribed angles, sector areas, all that stuff. So let's take a circle. All right, we've got our circle. We've got a dot. That's the center. For take it for what you will. Let's draw a central angle. Okay. So first thing, the central angle. So let's say this angle is, I don't know, 120 degrees. Sure, why not? Say this angle is 120 degrees. So if this angle is 120 degrees, what is the angle of this arc? Well, remember, if it's on the center, the arc is exactly the same, right? That's when your projector is in the perfect spot, and it just fits the movie screen, okay? So this is the perfect spot. So if your angle is in the center, it makes an arc that is the exact same length. So if this angle is 120, that means this arc is 120 degrees. Done. Okay? So now let's go on to a couple of the other things that you could do with this one picture. So the first thing they might ask you to do is, what is the length of this arc? Okay, so before we do that, I first need to give you a radius. Let's say the radius is, I don't know, 4. Okay, say the radius is 4, this arc is 120 degrees, or this angle is 120 degrees. So I'm going to find the arc, the length of the arc of this arc right here, okay? So arc length is just a piece of the circumference of the circle, okay? It's not the shaded area in here, it's just this piece. How far is it from here to here, okay? So 2 steps. The first step you want to do is figure out how much of the circle 120 degrees is. So what I'm going to do is I'm going to say 120 degrees out of 360. That will tell me how much of the circle I'm using. 120 divided by 360, well, that's 1/3. Cool. I'm going to change this over here off of 4, and we're going to make it a 6 because math. Okay, so I'm going to have 6. And then, again, this arc, so sorry, that's 1/3. That's the ratio of how much of the circle I'm looking at. Okay, so I want the arc. Arc is the distance on the outside of the circle. So the distance around the entire outside of the circle is the circumference. The formula for the circumference is equal to 2 pi times the radius. Okay, so the radius is 6, so 2 times 6 is going to be 12 pi. So I have 1/3 times 12 pi. Hey, look, 12 I can divide by 3. Hey, look at that. It almost makes sense as to why I changed it to a 6. Okay, so I'm going to have 12 divided by 3. That's going to give me 4 pi. All right, so that means this distance right here is 4 pi. Don't do any more. Leave it in terms of pi. That's how the test is going to be. That's how I want it. It's easier. Okay, so the arc length of A to B is 4 pi. Cool. All right. Now let's do another problem they might ask. They might say, hey, well, cool, you found the arc. Well, how much of the circle have we shaded? What's the area of this circle? Okay, well, If I want the area of this shaded region, I probably want to find the area of the whole circle. Okay? So the formula for area of a circle is pi r squared. No, they're not. They're round. Durr. Anyways, pi r squared. So we want to figure out what the area of the shaded region is, so I'm going to be using this formula. So basically what I'm doing here is I'm replacing this circumference with this formula. I'm still going to use this 120 over 360 because this is the portion of the circle I want. I don't want the whole circle, I want this 120 out of 360, or this 1/3. Okay, so now I'm going to say 1/3 times, let's change that color because it's hard to see, 1/3 times pi r squared. So r is 6, so 6 squared is 36, so I'm going to have 36 pi. I can divide 36 by 3, and that gives me 12 pi. And that is the area of that shaded region. And we're done. Again, that's it. Leave it in terms of pi. Don't do anything more than that. Okay? Real quick, so at the beginning of this picture, we talked about the central angle. So I want to show you the other option you could get with these angles. So say I pulled the arc back here. Okay, let's say this is still 120 degrees, is how much that arc is. But what is this angle here? Okay, this angle, so here, it's in the perfect position, right? And so this 120 degrees makes a 120 degree picture. Now if I pulled my projector back, that picture is going to be bigger. Just think if you had a projector in your house, you pulled it back, the picture on the wall would be bigger, right? So that means this picture is bigger than this angle. And here's where this section has a lot of 1/2s or times 2's. So this picture is 120. It's bigger than this angle, right? The angle doesn't change when you move it back, just the picture. So this angle is 1/2 of this. So that means x is equal to 60. So again, a central angle, these two are exactly the same. An inscribed angle, the angle is half of the arc, or the arc is double the angle. Either way you want to do it. Okay. That is the first section of this. I'm going to split this into 3 shorter videos, and so that's going to be the first one. That's it. We've got central angles, arc length, sector area, and blah, blah, blah. What's that? Inscribed angles. So let me give it a quick 30 seconds. Oh, one more section. Oh, there is more that I did in that first section. Okay, so let's do a couple more things real fast. It won't take long. Okay, a couple more rules. Again, like I said, I'm literally opening up the test and looking at it. Okay, so now let's take a circle and inscribe a quadrilateral. Right, we take a quadrilateral and inscribe it. So I'm going to steal or use some big fancy Sharpies that are a little fatter. So let's say this, here, let's label it first. A, B, C, D. Okay. So this arc right here, B, okay? So remember this arc right here makes this angle, or that angle makes this arc. It goes from A to C, right? Then I take another big fat Sharpie, and let's go with blue this time, and let's look at this angle, angle D. Well, angle D is from A to C also, but it's the other way. Look at that. That is the whole circle I just covered up. Okay? So the rule here that I want you to see. So this whole thing, that covered the whole circle, right? But it's an inscribed angle. So these inscribed angles don't add up to 360. It's half of the arc, right? So if this and this add up to 360, that means these two angles have to add up to 180. So when you have inscribed quadrilaterals, the opposite angles add up to 180. So this plus this equals 180. This plus this equals 180. So let's just do a quick example. Let's say this is 5x and this is 2x plus 4. How would I solve for x? Well, I would say 5x plus 2x plus 4 equals 180. And I would solve that. I have no idea if this is going to work. Let's see. So 5 and 2, that gives me 7x plus 4 equals 180. There we go. Minus 4 from both sides. We end up with 7x equals 176. Watch this. This is going to be fun. Alexa, what is 176 divided by 7? All right, Alexa just told me it's 21.1429. Hey. Yeah, that didn't work out very well, but that's okay. So x is equal to that. We're done. Solved the problem. Okay? The one on your test will not give you some ugly question you have to ask Alexa for. That's it. That's one of those parts. All right. Last part of that first section. Say you have a circle. Hey, you would think this test is like on circles or something, right? So this 3 and 6, and this is let's say 2 and x. Okay. When you have chords, remember chord is a line that goes from one end of the circle to the other end of the circle. It doesn't have to necessarily be a diameter. It's just a line going across the circle. When you have them crossing like this, it's a weird rule. This times this, so 3 times 6 is equal to 2 times x. Okay? So to solve that, that's all you do. You just set it up. What's 3 times 6? Well, that's 18. 18 equals 2x, right? Which means x equals 9. And we're done. All right, section 1, finito. Yeah, all right, I'm going to go on to section 2 in the next video. Enjoy.